Now we're going to see the slope of a line in 3 dimensions. That is, in order to find a line in 2 dimensions, as you recall, you need the slope m and a point that passes through that line. In 3 dimensions, in n dimensions is the same. You need a point and the slope of the line. But how are we going to find the slope of the line in 3 or more dimensions? This is if you know the angle between the axes, between, for example, in 3 dimensions would be the angle between the line, for example, this line, this is in 2 dimensions, this is in 3 dimensions. If you know the angle between this line and, let's say, the C component, the C axis, this angle, if you know the angle between the x-axis, the x-axis is here, so this angle, and the angle between the line and the y component, that will be this angle, then you know exactly how, at which angles is the line, so you know like the slope of the line. So we're going to find, first you could say like a formula of how to find the slope of the line, and next we're going to calculate this problem that says, sorry, I forgot to write it. It says find the directional cosines. We're going to touch this in a minute. Alright, so what we want is just the slope of the line. So that is just the direction of the line. It do not depend on the, let's say, the scalar component. That I mean, we just want the direction. We don't want exactly the vector. That is, we want just a unit vector in the direction of the line. As you recall, this is the equation of the line in 3 dimensions. You know that this, the vector 6i plus 3j plus 2k, is the vector that has the same direction, or you could say that is parallel to the line that has this equation. And this equation passes through the point 1, minus 2, 1, minus 2, here it's plus 2, 1, minus 2, 4. The important here is just the direction. So this vector is in the direction of the line. So we want a unit vector in the direction of the line. So let's calculate the magnitude of this vector that is parallel, that is in the same direction, and then divide this vector by its magnitude, and we will get the direction. So the direction of the vector is equal to the root of 36 plus 9 plus 4. This is 13 plus 36, root of 49, so 87. So the unit vector in the direction of the line in space is 6, 7, I plus 3, 7, j plus 2, 7, k. This is the direction in the line. Now, alright, once we have the direction, or let's say the unit vector, now how do we calculate the angle of this unit vector with the axis? That is, if you remember in the dot product, in the video of the dot product, we talk about the cosine, that is, let's say a dot b, vector a dot vector b is equal to the magnitude of a times the magnitude of b times the cosine between the angles. We saw that if a and b are unit vectors, that is, that if their magnitude is 1, you have that a dot b will be the cosine. So for that is important, or for that we are calculating the unit vector in the direction of the line, because we want to calculate the angle between the line and each one of the vectors. the vectors that are the axes. So we have the angle between the line and the x-axis would be the unit vector b, let's say, unit vector dot the I vector. This is 6 3 6 3 2 dotted, that is 1 0 0. Next, this would be the, you could say this, but because these two vectors b and I are unit vectors, we have the cosine of the angle between the direction of the line and the x-axis. So we will say cosine of theta, and this is called the alpha angle. So I will put the cosine of the alpha angle. Next, for b dot j, this will be the angle between the line and the j and the y-axis. So it would be 6 3 2 dotted 0, 1, 0. This will be the cosine of beta. Next, b dot k, 6, 3, 2 dotted 0, 0, 1. This is cosine of gamma. Alright, so now the dotting, as you recall, we need to dot each term of this vector, which is each term of the other vector, but because I dot k and that is 0, and also, even though they are not 0, when you multiply this 3 with this 0 would be 0. So first, when you multiply, or you do dot, when you dot I with j, or j with k, or k with I, you have 90 degrees angle, so the cosine of that would be 0 and that's 0. So you just have to dot the I component, the j components, and the k components. And so you have 6 plus 0 plus 0. So you have that the cosine of alpha is equal to, I forgot in each one to divide by 7. So divide by 7. So here's 6 7 is the cosine of alpha. Now the cosine of beta would be 0 3 7 0. So this is 3 7. And this is finally 0 0 plus 2 over 7. So these are the directional cosine, because the cosine tells us the, when you do arc cosine, then we have the angle of the line with the axis, and that is how we know the slope of the line. So as you can see, it's just to calculate the magnitude of a vector that is parallel to the line in space. Then that unit vector we dotted with each one of the I, j, and k vectors that are also unit vectors in the direction of the x-axis, in the direction of the x-axis, y-axis, and z-axis. And you will have the cosine of the angle between the line and that axis. So because you are multiplying, or you are dotting the unit vector in the direction of the line with the unit vector in the x, y, and z axis that are just 1, 0, 0, 0, 1, 0, and 0, 0, 1, the directional cosines are just the component in that axis, that is the directional cosine of the line and the x-axis is just the x component of the unit vector, that is 6 divided by 7. The directional cosine of the line and the y-axis is just the j component of the b vector or the unit vector, that is 3 divided by 7, and so on. If you want to calculate the angle, it's just arc cosine.